Hey guys, my name is Tensor. Welcome to another Flutter tutorial. In today's tutorial, I will be showing you how to implement Firebase into a Flutter application. Let's go over the boilerplate before we get started. So I've just got our main function, and then that points towards the stateless widget called myApp. We've got a material app being generated here, and I've made it so that the theme data in this is light, and I put a title of Firebase example. Then we've got a home stateful widget, which is being generated inside of our material application. And because this is a stateful widget, we have a second class called homeState, which is generating the scaffold. For those of you who do not know what Firebase is, it's a real-time database that is hosted in the cloud by Google. If you have a Google account, you can create a Firebase database. And you do that by going to firebase.google.com and then going to the console. In here you can then create a new project. So you click Add Project, then you put in a name, and you fill out the region for the project, and then you hit Create Project. In my case, I've already created our project. Once you've created your project, you'll land on a page that'll look something like this, except it won't have the applications here. You'll have to add applications, and because we're working with a Flutter application, we want to add both iOS and Android. Now, if your application is not for production and you're just building it in one of the platforms, you do not need to follow the steps for the other platform. Inside of your project, when you click Add Another App, you can click the platform that you want, and you can choose between web, Android, and iOS. When you click iOS, it'll ask you for the app name, which is the iOS bundle ID. In the case of a Flutter application, your bundle ID for iOS will be the same as a package ID for your Android application. And you can get that by going into your main.activity.java or main.activity.kotlin file and just pulling it from the top. So in my case, it's com.example.firebase example. And then we want to download this Google services-info.plist file and put it into our application directory. And for our Flutter application, that directory will be inside of the iOS folder and then inside of our runner folder. And you can see the file itself has all kinds of different strings inside of it, which allows the iOS platform to communicate with Firebase. There'll be a few extra steps that you can use to set this up. I do not, however, have Xcode or CocoaPods installed on my computer, so I'm not going to follow these steps. Now let's look at setting up Android. It's pretty similar. So you click Android, you put in the package name, and then you want to get the google-services.json file, and you want to put it in your root directory for your application. If you look here, it's inside of my app directory, so right here, google-services.json. Then it will tell you that you want to add some dependencies to your build.gradle on both the project and the app level. And for Flutter, you do not need to add this line, but you do want to add this line and this line. And following these steps will set up your Flutter application to use Firebase for both Android and iOS. Now we do want to bring in some dependencies for our Flutter application. I'm going to bring in Firebase database. Firebase core is just a dependency that gives you a few little extra things that can help. So the current version of Firebase database at the time of this recording is 0.4.1. And then Firebase core I put in any because the latest version doesn't build properly with Firebase database. We can now come into our main application and make our imports. So we want to import Firebase database, Firebase database.dart, and then Firebase database UI, Firebase animated list.dart. The next import we want to make is for Firebase core, so it's just Firebase core /Firebase core.dart. And that will get everything set up for you. Back inside of your Firebase console, you want to set up your real-time database. So you click database, and then it will ask you if you want a Firestore or a real-time database. We want the database, so you just click get started. And I want to enable this in test mode because I don't really care if people are reading and writing to it. but generally if you're using this inside of a production level application, you'll leave it in locked mode. So you just click enable and this will build out the database. Now, Firebase Core allows us to access our database directly from Flutter rather than having to rely on the platforms. So what we can do is we can create a new instance of our database by instantiating a Firebase application, and then we want to fill out the options for this. So for Android, you want to put in the Google App ID, the API key, and the database URL. And all these fields can be found inside of your google-services.json file. For iOS, you want to put in a GMC sender ID instead of the API key. And this is inside of the Google Services info plist file. Now, because I'm only building this application on Android, I'm not going to worry about putting in the iOS information. Alright, so now let's set up the model for the data that we want to be able to push back and forth from our application to our database. I'm just going to call this an item, and each item will have a key, a title, and a body. The key is auto-generated by Firebase, and then the title and the body are two fields that we're going to put into the Firebase database. As such, we don't need to put the key inside of the constructor, we'll just put the title and the body. We then want to create two methods which will allow us to both get and send our data. So the one that will allow us to get our data will be this item from snapshot method. Firestore sends what are called data snapshots to our application. So we need to get those data snapshots and then get the information out of them. So for the key, we just call snapshot.key. And then for the title, we call snapshot.value, and then we pass in title as a string, sort of like if we were accessing a map, and we can do the same for our body. And then our toJSON method will take our information, convert it into a format that looks like JSON, and then send it out to the server. Alright, so now let's build out our user interface a bit. So I'm just going to have our scaffold have an app bar. The title will be FB example for Firebase example. And then I want to set this resize to avoid bottom padding property to false. And this will make it so that when we pull up the keyboard, it won't resize any of our elements. I'm doing this because we're going to be using a lot of flexible widgets, and they will resize automatically when we pull up the keyboard. The body for this scaffold will be a column. And then we'll have two flexible widgets inside of our column. Our first flexible will have a flex of 0. We'll give it a child of center, and then we'll put a form inside of it. The form will have a child of flex, and we'll give it axis direction of vertical, so it's sort of like a column. And then we'll put the children in it, which will be two list tiles, each of which will have a text form field and an icon. So the icon will be in front of the text form field, and then the text form field will be empty by default. So we have this initial value empty string. And then below them we'll have an icon button which the user can push to send the information to our database. Now our second flexible will have the list for all of our elements, but before we build that out we need to create some global variables. Now we want 4 global variables. One will be a list of items, so this will be the list that will hold all the items that the user has passed into the database. And then we'll have a single item. Then we also have our database reference. And then finally we want to have a global key with form state inside of it for our form so that we can validate, save, and then get the information out of our form. We can now override our init state function, and we'll take our item and we'll set it to an item. We'll put in 2 empty strings, and then we can get a reference to our database by calling final Firebase database and then passing in the app variable that we created up at the top. And then we can get a reference to our path called items specifically by calling database.reference.child. Now I mentioned before that we do not need Firebase core, and as such you wouldn't always have this app variable. And in that case, if you wanted to gain access to your Firebase database instance, you would write it out like this. So you'd say item ref equals Firebase database instance, reference, and then child, and then you put in the path name. And this would allow you to communicate with your Firebase database by passing a message to the platform that this application is built on. By doing things the way that we're currently doing them, we sort of bypass that by using the Firebase core library. Now let's create a function for when we submit the form. So we want to get our form current state by calling form key current state. So if we can validate our forms, then we want to save our forms. And this will call the onSave functions that we haven't created yet. And then we want to reset the forms, which will reset them to our initial values, which are those empty strings that we had before. And then to push our data into our Firebase database, we just call itemref.push.set, and then we take our item, and then we call to JSON on it to convert it into JSON. So now we can come down here and put our handle submit function into our icon button, and then we want to come up to our form and put in the form key, and then we also want to create the validator and the saved functions. So for the top onSaved, we'll just take the value and we'll put it into item.title. For the one below it, we can just take the value and put it into item.body. And then both of the validators for these fields will be exactly the same. We'll take the value, and if our value is equal to an empty string, then we just want to pass back our value. And if it's not equal to an empty string, then we pass back null. Now, if you remember the input field tutorial that we did before, when we pass back null for our validator, then calling the validate method will come back as true. And if we pass back something else, then it comes back as false. Alright, so now we have the ability to pass items into our database. However, we don't have the ability to display them, nor do we have the ability to essentially update our state. Now we could call setState over top of this logic, but the way I want to do this is by adding an event listener. So we'll create two stream listeners. One will be called onEntryAdded, and the other one will be called onEntryChanged. OnEntryAdded is pretty basic. We just take in the events, and when we get an event where the child has been added to our database, then we call items add, and we take our event, we convert it into a snapshot, and then we instantiate it into a new item, and then put it into our events list. For our onEntryChanged function, we'll look at our items list, and we'll check to see where there's an entry that has the same key as the one that's being passed through our event. So if that comes back as true, then we put the item into this old variable. Afterwards, we'll call setState. We'll take our items list, and then we'll call items index of. We'll pass in the old item, which will get us the index, and then we'll take the event.snapshot, so the changed item event. We'll take in the snapshot data, and we'll convert it into a new item, and we'll push it into our items list. So this will make it so that even if we change the item from the back end, it will update how our application views our items. Alright, so now finally let's build out the Firebase animated list. So we need to put in a property called query, and we point this towards our item reference. And this tells the animated list where it should be listening on. And then, like with a list builder or a future builder or any other builder, we have this item builder property. Except with our Firebase animated list, we have 4 different properties that we're sending into this function. So we have our build context, we have the data snapshot, we have the animation, and then we have the index of the item. In our case, we're just going to return a list tile. We'll have each of them have an icon, and it'll be icon's message, so it'll just be a little message box. And then the title will just be itemsindex.title, and then the subtitle will be itemsindex.body. So now let's run this application and take a look at what it looks like. Alright, so here's our application. We have 2 input boxes, and if we just leave them empty, you'll see that they don't validate. So now I can type in some items, so just hello world, and then when I hit submit, it then pushes it into our list. And if we look at Firebase, you can see now we have this items table, and if we open it up, we have this little hash, which is our key, and then inside of it we have the actual document, which has a body and a title. And if we add more, you can see it gets updated in real time, and I can come in here and edit it, and if I edit it, you can see it gets updated inside of our app as well. Alright guys, well I hope you enjoyed this tutorial. If you did, feel free to like and subscribe. If you have any questions or comments, feel free to leave them in the box below. And if you disliked the video, then by all means, downvote it as much as you like. Have a good night.